Hi there. In this short video, I'm going to be showing you two options about illustrating your means. So, let's assume that you've just completed either an experiment or you've collected some observational data and you want to be able to infer findings, whatever it be, from that data set. One of the most common and basic ways to get a quick snapshot of differences between different data groupings is by plotting the means. In this video, I'm going to show you two different ways to do so. The first being a bar chart, where there are error bars, little handles attached to the top of the bar chart that indicate the standard error, plus or minus one standard error. Okay? And then the second one is called a means plot, and it actually plots the confidence interval instead. So I'm going to show you these two and talk through kind of the difference and what you may need to take into consideration before using either of these. So first of all, this is the error bar chart. This hypothetical greenhouse experiment data, well, at least the graph, it is not my own. It comes from Penn State University, the Department of Statistics online program, in particular a Stats 502 course. It's a great course they've put together teaching the use of data inside of an ANOVA setting, going into lots of great things like MANOVA, ANCOVA, ANOVA. And this is one thing that they teach in the course, how to illustrate your means. So, first of all, this first bar chart, you can see here, the top of the chart is the mean for these different data groups. And then the little handles here, this is the standard error, plus or minus one standard deviation from the mean. Okay? And what we're looking at here is just if you have a control group of plants that were planted and not given any fertilizer, this is where you expect to see them, their height growth to. And I'm guessing the coursework doesn't explain in detail the actual experiment, but I imagine they had numerous plants, a good sample or a good cell size for each of these different segments. So let's say maybe they had 20 plants in the control group and then 20 plants in each of these other groupings, and then these other three groups were given fertilizer, potentially different types of fertilizers or different amounts of fertilizer, and we can see the mean difference here as well, as well as the plus or minus one standard deviation. So this is plotting out the standard error. In the next plot, we see a means plot. And what this does, this is very similar to the other one in that it is plotting the means. The circle in the middle here is plotting the mean between the control group and the other three groups. But instead of using a plus or minus one standard deviation from the mean, these handles on this mean plot, they are actually showcasing the 95% confidence limit of the data. And when talking about confidence intervals, it's very important to say the right thing. So because this is plotting means, we would not say that for any other single sample observation or sample experimental participant in this experiment or observational data, whatever it is, we would not say that one individual, given the F2 scenario of fertilizer, that there's a 95% likelihood that they would fall within this range. What is it, about 20, probably 24.5 up to 27.5 on the height. That would be incorrect because this is a plot of the means. So if we were, let's say that the cell size is 20, if we were to take another 20 samples with the F2 conditions, we would expect those means to fall in here with 95% confidence. There's a lot of tricky things to saying the confidence interval. I am not an expert on this. There are some experts though out there. One of the things that they recommend saying for your confidence interval is that it is a range of plausible values for the mean. So values falling outside of this confidence interval are relatively implausible. That's a way that I've heard it stated. That is a pretty good safe bet. Anyways, this is showing you that about 95% of the time, the plausible values of an additional mean grouping would fall within this range. Okay, so this is the confidence interval chart. I'm afraid I probably just made it sound more complicated than it is. It's a great way to illustrate your means and kind of where your data is falling. So what is the big difference between these two? Again, leaning on the experts. So there are two professors in psychology, Jeff Cummings and Sue Finch, who published an article in the American Psychologist Journal in February-March 2005 period. And in this article, the article is titled Inference by Eye. They're talking all about reading data, specifically mean confidence intervals, mean confidence intervals, etc. So they are in their article, they are encouraging psychologists and other researchers to use the confidence intervals more than the standard error charts. And their argument is that sometimes researchers will use the standard error chart because the interval range is smaller and it looks smaller. And so it looks like your data is more, maybe you had more observations, or your findings are more, have greater statistical significance, whatever it be. They say that these smaller handles or whiskers, whatever you want to call them, on the mean can be deceiving. And so for that purpose, they encourage the use of confidence intervals. However, that said, bar charts, mean plots, whatever it is, showing, if you use a bar plot or a mean plot, if you show the standard error or a confidence interval, it's really a matter of choice for you. It ranges depending on the conventions that are used in your individual discipline or journal that you're trying to write for. So take that into consideration. Use what works for you. I hope this little highlight helps you out. Thank you.